Hey guys, today I'm going to go over Unit 2, Lesson 1 in chemistry. There are a lot of vocab in this lesson. The main things that I'm going to go over are kind of the application questions that you might get stuck on. So it's a little bit less of like the vocab and maybe the history. If you need help with that, please come let me know. But I'm going to just go through some of the application type of questions from this lesson. The first thing that you are being introduced to that's really important is how elements look on the periodic table. So for example, this might kind of look familiar to you and you might know, okay, that's C, that might be carbon. And that's actually true. This is carbon. And I want to explain to you what these numbers mean on the periodic table. And so you can see that this is C. This is the element symbol in the middle. And so it's just an abbreviation for the element name. So some elements, they just have a really long name and you don't want to write out the whole name every time. And so we have symbols for them. So carbon symbol is C. Potassium's symbol is K. And so they all have symbols to kind of make it easier to understand. Sometimes the full name is written under here like carbon so that everyone can know that that's actually carbon. So that's the symbol right here. This number up at the top, this is always at the top. It could either be at the top left or at the top right or the top middle, but it's always at the top. This is called the atomic number, and it is probably the most important thing about the element. This is the atomic number. The atomic number is the number of protons that element has. That's what it is, the number of protons that element has. So carbon has 6 protons. The atomic number is what defines the element. So if an element has 6 protons, it will always be carbon. There is no other element that has 6 protons except for carbon. So if you change the proton number, you change the entire element. You no longer have carbon if you have 7 protons. So the atomic number is how many protons they have. So you can see here in this picture, this is a picture of what carbon kind of looks like. You can see the 6 red circles. That is showing you the 6 protons of carbon there. When you have a neutral atom, the atomic number is also equal to the electron number if you have a neutral atom, because positives and negatives would cancel out. So if you have 6 positive protons, then you're going to have 6 negative electrons if you're neutral, because neutral means that your overall state is 0. So if carbon has 6 protons and it's neutral, it's going to have 6 electrons. If you count these yellow dots, you should get 6 total. The first ring can only hold 2, if you remember, and then the ring after that can actually hold 8. And so all the remaining electrons are put here for a total of 6 electrons. And then this number down here is the atomic mass. It's actually the average atomic mass. The average atomic mass. Okay, so why is it an average? What does that mean? Well, the atomic mass of one element of carbon, one atom of carbon, is the sum of protons plus neutrons. Protons plus neutrons. So carbon always has 6 protons. So we know it's always going to be 6 here for carbon, right? But sometimes the neutrons can be different. And so the atomic mass is not always exactly the same. When you look at this picture here, how many neutrons do you see in this picture? Well, I see these gray circles are the neutrons. I see 6 neutrons. So in this circumstance here, there are 6 protons and 6 neutrons. And so when you add those together, you're going to get 12. So when you look at an individual atom, you can just sum up the protons plus the neutrons. But the neutron number can change from element to element. The proton number cannot change if you're dealing with that specific element, but the neutron number can vary between atoms of carbon or atoms of another element. And so you add them together, and then what you see at the bottom of that entire element is a weighted average of all of the isotopes. That's what it's called whenever they have multiple neutrons. So weighted average of all of the elements, because some of them have different atomic masses based on the number of neutrons. So that kind of goes into what I want to show here. When you look at this picture here, I want to break it down. The red that you see, the reddish one, is the proton, and the orange circle that you see is the neutron, and the blue that you see is the electron. So when we look at this picture right here, we can actually figure out a lot of information. You can see that it has one proton, right? It has one proton. And remember, the number of protons tell you the atomic number. And so if it has one proton, I can go over to a periodic table and look at whichever element has one proton. Well, that's going to be hydrogen. Hydrogen is number 1. Remember, the atomic number is how many protons they have. So if we looked at beryllium right here, beryllium has 4 protons. Hydrogen has 1 proton. So just by looking at this picture here, I know that we are dealing with hydrogen, right? It's got 1 proton, so it's got to be hydrogen. It's got 0 neutrons, if you see there. There's no other orange circle. And it's got 1 electron. And that makes sense because, like I said, the proton number will equal the electron number if it's a neutral atom, if it's in a neutral state. So this is hydrogen. If you look here, this also has 1 proton, right? And it has 1 neutron. But the proton number is what matters for defining the element. So this is also hydrogen because it still has only 1 proton. This one also has 1 proton, but it has 2 neutrons. Again, this is hydrogen because the proton number is what matters whenever you're defining an element. So they all have 1 proton, so they're all hydrogen. So what's the difference between them? What's the difference between these 3 images? It's the neutron number, right? The neutron number is the only thing that's changing. Whenever you have the same element, but different numbers of neutrons, they are called isotopes. Isotopes are the same element, but a varying number of neutrons. That's what an isotope is. So what would change about the element? Because it doesn't change the name, right? These are all hydrogen. Well, we said earlier that the mass is the sum of protons plus neutrons, right? So the mass here, the mass of this hydrogen, it's protons plus neutrons. That's the mass, right? So it would just be 1 plus 0, right? Because I have 1 proton and 0 neutrons. So the mass here would be 1. What would the mass be here? Well, the mass is protons plus neutrons. I have still 1 proton, and now I have 1 neutron, so its mass would be 2. The unit for mass, by the way, is actually AMU. It stands for atomic mass unit. And then the mass here, again, is protons plus neutrons. So it would be 1 plus 2, which would be 3 AMU. So you notice these are all isotopes of hydrogen. The only difference between them is their mass, right? And to notate that whenever you're writing it out, is you can put a dash next to the name, and then you put the mass that it has. So this is hydrogen 1 because its total mass is 1. This would be hydrogen 2 because its total mass is 2. And this would be hydrogen 3 because its total mass is 3. So if you see an element name and then a dash and then a number, the number after that dash, like in this situation right here, this is telling you the overall mass. It's not telling you the proton number. It's telling you the overall mass. So if I see hydrogen dash 2, right? And I know that hydrogen has an atomic number of 1, then I know, okay, 2 minus 1 is 1. This hydrogen has 1 neutron and 1 proton, right? And if I see the name hydrogen dash 3, like right here, I know, okay, hydrogen has 1 proton. So this hydrogen must have 2 neutrons, right? 1 plus 2 makes 3 to get that total mass. So this is how you notate isotopes, and you're going to have some practice problems like that.